Okay, we're going to go over every one of these things slowly through a video, and just so that people understand and get, if they ever want to make their own custom multiplayer UDP stuff, they kind of understand how the approach of this game went and what was done to make it pretty nice. So everything is customized for, the only thing we're doing is using UDP client C#, and then we do everything else by hand. Everything is done by scratch other than that class. So first thing we're going to start off with is talking about using arrays. And like I said earlier, don't use span T and memory T, and this is because I tested first, of course, many times, and the reason is because the functions for send, I think sending requires an array, and then if it's not an array, you have to do two array, and the problem with that is that it takes longer and is less performant. So reusing arrays means that you shouldn't have to create new arrays. If not possible, you shouldn't have to copy from one array to another. You should just think about reusing the array if possible. And the thing that also should be stated is that you basically think of it like a circular buffer almost, except that it's not going in a continuous circle. You're just kind of basically rewriting the data over what you have, and so that this keeps it as fast as possible because you don't have to do any copying from one to another. That takes way too long. If you can use the data as it is, please use it. Using send and receive should be asynchronous. Receive will be probably some kind of thread, will be blocking most likely. So you have to have a thread to kind of read that. On the send part, you want asynchronous, but you don't want it to be asynchronous when gathering and getting the data ready. The reason I want to say that is because you may have something where you're doing reliable UDP and then certain things have to happen in a certain amount of time. So maybe at the beginning where you want to check and see if data needs to be sent out again, or you're checking to remove data from your list of you've already received and whatnot. When you go and do this, if things aren't in sync, you're going to have problems. So you can make your send asynchronous, but I think you have to prepare it in a certain way, certain fashion. The reason it has to be also asynchronous is that you can't really do lag simulation without it. You need to add delay and whatnot. So doing the send and resend, we can kind of just look over some code here. I'll go to send data and open this up. So what I do is I check and see what kind of case am I sending for. Is this data that needs to go out? Is it reliable reply? I mean, there's different cases. We can go look at the enumerators real quick. So here's my send cases, and then this is the main starting. So when you start to program this up, you're going to want to do some kind of connection. You can do like a handshake, basically checking to see if the connection should be considered, and then acknowledge on the server and say, okay, I'll accept this. Otherwise, you're going to have to just block every message after that and say, you know, I don't accept these messages anymore from this address. And then you move into doing stuff, probably starting with like ping and then pong, which is basically, just think of it as ping, I guess, pinging back and forth. Ping would be that the send off, and then the pong would be the reply back. The microphone is something you may do at some point, but that's a little bit more complex at the beginning. I think that's something I don't think somebody should try to take on right off the bat, especially considering how complex UDP already is. So going back, let's see here, send data. So what we do is also get ready for a sequence. A sequence is going to be basically telling how the data, if the data is old at least or duplicated. you will not be able to tell which without keeping basically caching every single message that you receive and saying, okay, well, I already received this before, then it's called duplicated, but you don't really want to do that. So you just want to know if the data is good, and that basically requires a sequence. Now, a sequence is to let you know if something's older than something else. So if you start at 0, a sequence number, and then you go ahead and you send up to whatever you can maximum, you'll know that one after the other which one's older. If I got 0, that's the very first one. If I got 1, that's the next one. It's newer than the 0. When I do this, it's a little interesting because I use array sequences. I don't use just like a one sequence. Some people use a reliable UDP with that. Well, I've never seen anybody use array sequences. I think I might be the only one, but who knows, because it takes so much damn programming to do array sequences. But there's benefits, of course. I think better benefits, in my opinion, from all the tests I've done and whatnot. But point being is that when you do unreliable sequences, you need to start at 1 at least, because you're going to have a problem if you don't. And that goes up to the max that it can, but also making sure that the sequence you add don't get above that. So they start back at 0 and they're always 1 behind, so that you can always be 1 ahead for sequences that get received. That's for non-reliable. For reliable, you actually can use the same, I believe. You can actually check, because I don't really remember, to be honest. Where we do this is just in the classes. So let me close this right here, go over to the classes. And non-reliable does start at 1, like I was stating. So my buffers, my sequence buffer starts out like this, 0 to 255. I'm just using 1 byte. So on my send, I do 3 bytes, 2 for the data send case, and the third one being the notice of how old the packet is. To use a byte buffer, you have to use array sequences, so that's going to be extremely difficult for other people to kind of do in code. They may choose not to do that and send an integer instead. So I'm sending a byte, which is very, very tiny. An integer would be 4 bytes, but depending on what you want to program, what you want to do, I mean, you pick your battles, right? I, of course, want to try to go for the most efficient way, and it requires way more code, way more complexity, just because of the possibilities and what you have to put in the effort for. So let me go ahead and close this up. And we'll go back to send, talk a little bit more about the sending. So there's a thing called filling a buffer. The thing about filling a buffer is you prepare the messages that you're about to send and you wait till the end of the frame to send them. So like through your update, you prepare everything. I'm going to send this, I'm going to send this, I'm going to send this, and you put it into a buffer of bytes. The buffer that I use is 1024. 1024 I think is about average. Steam uses 1200 as the maximum that you're going to get, from what I understand. So that's the most I could throw into a package anyways. But the reason you also need to do this, especially when sending and setting up a buffer, is that you decide if you want to send all the data. Now, sometimes you will want to send the data. You will want to send it immediately, something like connecting. You want to say, okay, I want to send this right now. I don't want to wait till the end of my update to send all the things that are connected to it. But in other cases, you're going to want to wait. So like, for instance, you may want some transformation data or some projectiles that send data. All that stuff you're going to want to wait till the end and send it as one package. And the reason for this is maybe if you're using reliable UDP, because honestly, if you don't have reliable UDP and you're doing something like this, you're going to be up a creek with making a very nice multiplayer, because you have to have reliable UDP. And the way you do that is, of course, you send a message with a header that's different than, or actually you don't need to send a header that's different. You can send it, well, technically the header is different. It's just got a different data send case. But I mean, the header could be the same amount of bytes, of course. So I'm always sending 3 bytes as a header, and the fill, I should talk more about the fill buffer, is that you can choose which data you want to send. So mine for the microphone, obviously I send the microphone as by itself, all that it can. I don't fill I don't think I fill a buffer with microphone. Doesn't really make much sense. But for like everything else, projectiles, world information, stuff like that will all be buffered. And then once the buffer is full, it's checked before sending any more data, sends it, and then remakes a new, or refills the buffer again. So we have in here, fill buffer is true by default. And then we also have reply. For reply is basically here is for the reliable UDP saying, hey, I got my message, reply back, please stop sending that because you don't need to anymore. And if we go down, we get these sequences that are increased. So here's an interesting thing, is to show how to not to recopy and whatnot as much as possible and get your sequences in, is that I actually start with a 0. So if I go over here and I go gsend data, so we see here's my 3 bytes. So I've got 1, which is the beginning send case, and we'll go a little bit over that, and 2 is the actual data send case. 0 is my byte sequence. So it starts at 0, but it goes into the send and actually gets accumulated here depending on which array sequence it is that is being used. It's going to look like a lot of code, obviously, and the reason is because there's so many array sequences. Like I said, it becomes a lot more and a lot bigger, but overall the gameplay I think is worth it. I'd rather write more code to get something working much more better if that's possible. This concept is very extreme, I think, using array sequences. So if anyone else out there ever does that, they'll have to agree with me and realize that, oh my God, this is just a crazy mission to try to fulfill that and keep doing it, or keep it. Most people would just say, you know what, I'm done with this. I don't want to write so much code. So, but so we send this in, and then we just change the byte sequence here by checking what our index is going to be. So you have a byte. I do, at least have a byte. You would have probably an integer or whatever you're going to use, and the byte just gets added up to every time I want to send data. Gets plus equals 1, and then eventually it restarts over. Starts at 0, or actually, I think that those always just go back right to 0, from my understanding. And then if we go down, let's go down a little bit here. So we check if it's a reliable packet. If it is, then we store the packet information, because we're going to resend it later if they don't reply back. And then we have if we need to fill a buffer or we need to send data, and then we go into the lag simulation. So let's go to this definition here. And here's where we do our asynchronous, and then if we're going to do a lag simulation with a delay, we're going to have here, and then that way we can actually get where it feels like it's laggy. If you want to do that, I would highly recommend having to do that. Otherwise, you go into the send data. So we go to this definition here. This uses Steam if we want to play Steam. If not, you will have to have a try, because most likely sometimes I think even with reading and sending, every example of code that I pretty much went across will have a try, write to send or something, because they don't really have any other way of saying, okay, this didn't work or something. They give error if it wasn't able to send, or if it wasn't able to receive because of some problem in the middle of. I guess you could have a disconnection as it's happening. I don't really know, but that's what is shown in a lot of the code that I went through. It's basically, this other code is for showing packets and whatnot. So that's basically going over what is needed for sending. Let's start at the top here. What else do I maybe want to go over? Okay, let's go over receiving a little bit. Actually, I want to go over the enumerators and kind of explain. So the send data case, basically it's kind of like, I want to say it's almost like knowing your opponent's move if you're playing chess, kind of, or kind of relating to tell, hey, I'm going to do this, I'm going to move my rook forward. It's kind of like that. It's basically, think of it kind of like an event, but it's not really an event. It's just symbolizing that this is what's going to happen, and here's the message, and you know what to do with it because you are the one programming it. So if I write down something, you want to come up with a way to tell yourself what it is, of course. So here I have HC for host to client. Some other people may use whatever they want, but at the end I have R for reliable, so I know if it's reliable or not. I have non-reliable, which is NR, and then R for reliable. So we can see here I have client input. Client is sending to the host input, and host is sending to the client input. Now, another thing to note is that these are situated also in another section of code which tells me how much the return is. So my byte header is 3. Personal byte header is 3 bytes, but then if people know anything about UDP programming, they would be asking how in the world is that low? Well, again, I don't use a reflection. I don't use any of this stuff because I know what I'm sending. And if you know what you're sending, you can actually acknowledge to yourself in code when you get a message and whatnot how long your package is, your message that you received. So if I know I'm going to send something like a projectile and that's all I'm receiving, I look up in my code saying, okay, that's going to be maybe actually I think it's something like 7 bytes long, and it will take the 7 bytes out of the entire packet if it's full of a bunch of stuff. So that would be the first one. So it would take out the first 7 and acknowledge, okay, this is a projectile. What do we have here is the personal header in the front. So I know it's a projectile because of that reason, the front of it. But also the back rest could be like an index to something for a projectile. So the front 2 data sync case would be telling me what kind of projectile. So it would be saying it was a cannon, it was the minigun bullet, or it was a missile. So basically, these are just, think of them again as events and kind of saying, okay, this is what I'm preparing to send. On the other side, this is what I received. Okay, I need to do this. So once you receive this stuff, you almost think of it as like switches. Like I need to make a switch for this. Okay, I received cannon shot. I need to acknowledge this is a cannon shot and do something that's cannon shot. Now, I use enumerators for this because I think it makes sense. You can't really put a number here because these are constantly changed and added to and kind of moved around. And I try to keep it organized in a way. This is what I started making it as, and then this goes down and that's how it is. But in cases, you're going to have to move stuff around. Now, looking at it, you see one numerator and one number, a single digit pretty much. Well, 20 is not really a single digit, but I mean like for the first byte, or second byte, excuse me. So I was talking about earlier that I send a 1 byte in front, and then this is the send case, and this is because of possibilities. So you could technically send 1 byte as your data send case of what's basically happening, but then you think about if you only send 1 byte, that's only 256 cases or possibilities, and then you start to realize that that's not enough for programming multiplayer. For a game that might have a bunch of stuff you want to keep adding on, it's not enough at all. So then you think, okay, well then I need to send 2 bytes. So the first byte is kind of cycling through the layers of what kind of events there could be, and then the second byte is actually the event itself, or I would say the data send case itself. So that's simply how that works, and that's why you'll see some of these saying like 1 is the first byte, almost always right now, because I haven't filled all my possibilities. Once I do, there'll be like 2, 3, and then they'll still say byte send case. But I don't know if that's ever going to really happen. It could possibly happen because I use array sequences. There's so many things I have to put out and write. But again, I think it's worth it for the experience of what the players are going to be doing in the future when they play it and go, wow, this is really nice, whoever set this up. But they don't realize how much goes into it is an overwhelming amount. So um, let's see here. So let's talk a little bit more, if we can, about the threads. So understanding the data send case. Let's go to receiving data. So we do a thread. Go into receive. There's Steam right there. Hope I'm not having a nosebleed or something. No. Okay. Let's see. So as we go into, we check if available. This is a thread that blocks this line, or not thread. This receive blocks, meaning that if you call this without a thread, your application is going to lock up. And that's why this needs to be a thread when receiving. And mine does a class and then does a thread, and then go ahead and create a new thread, and then the thread start it, thread run it. I think you could even actually put start here, maybe. Yeah, you could, but thing about like thread sleeping too, kind of just to talk about that real quick, is that some people would be like, no, you don't ever use system.thread.sleeping, but in some cases you actually very rarely would. Is for like, okay, I wanted to check and see if there's data, but there's no point checking to see if there's data because I just checked and I want to wait it out. And waiting it out actually lets the processor catch up and breathe. And what that means is that if I say let's sleep for 1,000 milliseconds, actually the processor would breathe a lot better than just checking every cycle. Just basically saying, okay, here, check again, check again, check again. And this is good for like connecting. Like let's say you want to delay a certain amount checking and allow the processor more to breathe. But when you start to accept data and you're playing in the game, you probably want to turn this off. So I call it sleeping chance, so the possibility of being on or off, basically, that's what that is. But going into preparing to receive, so let's go to the data here. We've got our try there, and then receive data now. Then we have in here, for doing like lag simulation, we want to do packet loss. So because of packet loss, we can check to see how the game runs, and I'll go a little bit over this later because it's absolutely important to know how your game runs when there is packet loss, because this is something that will definitely happen when somebody has a bad ping, bad connection, a router somewhere, getting a packet but not being able to recreate it and send it out. Something happens, maybe someone pulled a plug or something on that router. So and it could be a much older router, so then you're really yeah, I guarantee that there are old routers out there. So then we have receive. Go to receive now, and then going through the data. So like I was saying, mine can tell microphone, data sync, and terrain are not filled well, they are filled buffers for themselves, but they're not with any other data. So we automatically acknowledge, let's go ahead and just receive this data and do whatever we need to with it. And then if not those, we need to break down the data. So we get the position index, is what I was explaining earlier, is that I have this kind of lookup table, and you have to manually write this down, and this is just like somebody would say, well, that's too much for effing work. I don't want to have to do that. I'd rather use reflection, or it doesn't make sense to use reflection. If you're really using reflection for this, I'm going to laugh at you because you're just adding more layers of less code, sure, but the processing is going to become more of a joke when you have a ton of messages coming in. Also, you just writing these down by hand, I will agree that it is you have to be on the ball, manageable, you're walking through landmines. I'm walking through landmines all the time, and I'm very, very, very careful, very cautious. So I put down these numbers here, and I know right away if I make a mistake. And I go kind of slow on this section. When I start to write it, I count the data. I go over here, and I look at it, and I count it. So here's 3, and then here's 12, and then here's another 12. And so then I know that's 24 plus 3 is 27. So if I was to look this up, this sin case, which looks like something of a tank death, go back here, look up tank death, should be 27, here it is. So if I make a mistake, I have code that will basically tell me and write out, it will say you made a mistake, most likely in this type of return. And so then I just come in and recheck. So it's really not that difficult to actually set up a system to do it better, but people don't like to do that. They like to take the easy way out. They like to write less code. They don't really care about efficiency as much as just get the job done. So, but the lookup table here definitely has what you need to write down. So connecting, only sending 3 bytes. Basically, nothing else you need to send. That first data send case, 1, and then the second data send case saying connect. So this is the connect right here, you see. And then the third being the sequence. So you don't really probably need to send a sequence, but since the system is already being set up and to be consistent, just to use the same code, you just apply it, which is another reason why I don't use any code that performs and makes a structure with reflection and whatnot. And some people will try to end up doing that, but then the code becomes, again, inconsistent, and then also there is limitations with that in the structures. I can't remember all the limitations, but one of them I think was you can't use arrays for certain things in the structure, and especially then when reflecting backwards. From what I remember, I actually programmed everything out to see if it worked, and it did. But then when I came across all the complications and then the inconsistency of writing code, I didn't want to have where I'm taking a structure, taking it apart, building it back together, but then not always doing that. And that just to me didn't make sense. It's like, okay, I'm going to add another section layer of code that I'm just going to possibly use, but I don't necessarily need to. There's another way, of course, is that by hand you can actually restructure the, let's just say structure back together. So I kind of show that real quick. Let's go here. So here's our tank transformation struct, and then we go through and we just grab in the data, and then we check for making our vector 3s, and it's that simple. So if I actually go over here, so it is possible to, my camera is in the way. It makes it hard for me to see over here what's going on. What was I going to show? I already forgot. I was going to show, doing structs. So like receiving data for game. No, not this one. Not that one. This one here. No, you're going to be in receiving indexing, and then close this up. I'm trying to remember how this works. I'll just do it this way, a little easier. I think it's in, sequencing, now that I remember. Yeah, it's in sequencing. Okay, in sequencing, we see here new, so we just enqueue. You're going to want to use concurrent threads, or concurrent queues, excuse me. They are used for basically threading, but the reason is because you need to possibly add one message after another, or this data, let's just say. So you're going to want to use concurrent queues for the most part. I don't really use any concurrent stacks, I don't think, in any program that I do. It kind of seems weird that you don't use stacks, but I can kind of explain that later on. So I use queues definitely, but I don't think I use any stacks whatsoever. I tried to use stacks at one time, but then I think I proved on paper that the stack was not what was supposed to be used. It was supposed to be queued for inputs, which is kind of, I think in some cases was kind of strange, but it definitely was supposed to be queued from what I looked at. So here we just say equals new, and then we just pass in the data. So basically doing no reflection to put it back into a structure. And the only difference is that now we say we're sending data raw. And so you can see that consistently I don't have two sends. I have one that's just the data raw. And of course you have to kind of write it out, but technically if you were even sending a structure, you would still have to technically write that out. So again, if I'm talking about consistency, I am actually being consistent more than doing it the other way. So I think that's probably covering well enough the very first one, and that kind of goes over to covering number 2 as well. So I can't really think of anything else at the moment, but if there's any other questions, just bring them up and I'll go into more depth about that. Thank you for your time. Have a nice day.